We are Group 30, and our video game is called Escape from Foco. So to begin, we'll watch a short video of this gameplay being played in the C++ console. The game board is a 10 by 10 matrix in which you are the letter O, and you move around the screen with W, A, S, and D. You avoid NPCs which move randomly, and when you hit them, you lose a life. You have 5 lives, and if you lose all of them, you lose the game. There are 3 levels that the player has to progress through, each with more NPCs that move more randomly. On the final level, there are 6 NPCs here, and once you get past them all, you are presented with your score. The lower the score, the better, as the score is how long it took you to beat the game.
The work distribution was completed based on strengths, weaknesses, as well as individual interests. In our first group meeting, we talked about roles we wanted to try, as well as things we wanted to work on throughout the project, and created this breakdown as seen on screen. The roles decided were researcher, note-taker, head writer, team lead, graphic designer, lead programmer, chief of testing, head of level design, and lastly, software architect. In addition to these roles, each member was required to have a programming role that would overlap slightly within each of these individually assigned roles, to allow each member to try a bit of every aspect of the project. As for completion, the schedule was heavily influenced by each member's individual schedule as well as assignment deadlines. We aim to meet about once a week and follow the STD timeline we created closely, as well as internal deadlines created for the individual parts of the code. We aim to finish each respective assignment about 1 to 2 days early to allow time for editing as well as technical difficulties. As the semester came to a close, we did have to push back some of our deadlines due to many tests, finals, and projects building up between our courses, but still ensured everything was completed by the date and time internally set by the team.
Due to factors such as the size of our group and different schedules, we did not have time to implement certain features that is documented in the STD. For example, we did not figure out how to do graphical user interface on C++ and only had a console printed version of the game. Supposedly, from the GUI screenshots section of the STD, the game should have a main menu with a new game and stats option. And then we also have the in-game HUD, which stands for heads-up display, will show the number of lives of the player and items. There will also be a level complete screen once a level is done. None of these features are added since it requires a lot more time and GUI coding. We also mentioned a sort of menu selection in the STD that allows the user to select a level from all the 4 levels, which we did not completely add to the game. Also, one last feature that is mentioned is a sort of loading screen, which is mainly added with the consideration of having GUI. But the current version does not have a loading screen for any of the levels. So for now, the user only has to type in a character, and a game board consisted of ASCII characters will be automatically loaded.
During the course of this project, our group had a few difficulties that came our way. Although these difficulties set us back, we overcame some of them. A challenging aspect of this project was finding group time to work. With 8 university students who all have other assignments, projects, classes, and meetings, it became apparent early on that we only had a few windows to have group meetings. The easiest time slot to work on the project became the empty tutorial slot, which we started to take advantage of to convene and discuss progress. However, not enough work could be done then. Since we were all aware of our limited meeting slots, we instead delegated individual tasks to finish weekly, which became our method of getting work done. Besides that, we also decided to have group meetings even if all members were not able to attend, and instead filled them in on what happened during the meeting in the Microsoft Teams announcements. Another issue was that each of us had different levels of coding knowledge. This led to there being confusion on what parts to do, as some of us could not fully code entire sections. For those sections, the group got together, asked each other lots of questions, and figured out the best code to implement. Asking each other lots of questions created a good work environment, which enabled us to work better together in the long run.
After we had got our video game working perfectly in the console, we spent some time trying to get the GUI plugged into it. We faced numerous issues while trying to get the GUI to work, some being caused by group members with different operating systems, as well as having some issues that appeared for some of us and not for others. We tried our best to get the GUI working, and one that would display what was shown in the console, but unfortunately we could not get a working version up and running. The levels that we had planned were 3 levels in which the player must avoid NPCs, and 1 level in which the user drove a train and avoided obstacles. Unfortunately, with how the levels were set up and the logic within them, it was too difficult to implement the train level, as it was too different from the other levels. We had made attempts at implementing it, however, it did not work as intended, and thus we decided to cut the level from the game.
In programming, a library is a collection of precompiled routines that a program can use. They allow you to save time by not having to write your own routines from scratch, as well as potentially allowing you to accomplish something you would not have the skill set to do without the library. In C++, libraries can be accessed through namespaces and from hashtag includes of header files. A namespace is a declarative region that provides a scope to the identifiers, the name of functions, types, variables, etc. inside it. Namespaces are used to organize code into logical groups and to prevent name collisions that can occur, especially when your code base includes multiple libraries. There are groupings of related classes, the most commonly used of which is the standard namespace, or STD for short. Header files contain definitions of functions and variables, and thus usually contain much more specific routines than namespaces, which can contain several header files within themselves. It is generally considered bad practice in commercial development to use the using namespace line at the top of header files in case you need to use routines from several namespaces, and future updates to those namespaces cause what's known as namespace pollution, where the compiler doesn't know which routine to use from which namespace because they have the same name. A way around this while still saving the annoying typing time with writing out the namespace in 2 colons before every time you want to access standard is shown on the left, where you can just put it within a scope to prevent collision, or just specifically use a certain method from the namespace with using 2 colons before it and the specific method. So what do we do in our project? Well, we didn't do what best practices would tell you to. As you can see in the top left, we had the line using namespace standard in every header file. However, the rules that dictate best practices can be too rigid at times. For example, there are no other namespaces that we're using in our code, so pollution from namespace collision would not be possible even going into the future. Also, the scope of the project is important to remember as a developer. The scope of our project was limited enough that taking shortcuts such as we did was acceptable. The repo for a project will not be pushed and expanded further after this project in this term. We did use several header libraries like Vector and Chrono and Thread, which in the case of Vector saved a lot of time in the implementation of the NPC controller class, and in the case of Chrono and Thread enabled the existence of level intermission features for the game. This is an example of using libraries for their intended purpose. No need to reinvent the wheel if someone has already uploaded it to the internet.
In this project, we set out with high aspirations and detail of what we wanted to accomplish. At numerous points throughout the course, we questioned if we had been too ambitious and if we should lower our goals in order to meet deadlines. While there is always room to improve, we were able to complete almost everything that we had planned from the start. 2 things that we had conceptualized but not completed were the GUI and more complex levels. Almost all aspects of the GUI have been completed, from the tile board to the characters, to the starting screen along with the end screen, and most things in the middle. The part where we did not finish was implementing the code to bring it all together. The next step in this project would be to finish that up in order to present a more polished application. Additionally, we had planned for some more complicated levels. After completing the first set of levels, we realized that there were better uses of our time and dedicated it elsewhere. While we are happy with the results, this added level of complexity would have increased the overall significance of the application.
Although we were able to successfully produce a finished product that met most of the design goals outlined in our SDD, there are a few key areas that we choose to approach a bit differently. One of the primary things we struggled with was that the work done in our group meetings was somewhat disjoint, as a large group size and differing schedules meant that it was hard to get everybody in the same meeting at once. In hindsight, it would have been easier to define a weekly meeting schedule prior to starting the project, which would have allowed everyone in the group to consistently get work done together. We also faced challenges with how programming tasks were delegated. Because we each had varying levels of coding ability, some group members were better equipped for problems within their area of expertise. Rather than assigning tasks at random, it would have been better to take a closer look at what each task entailed and then assign the tasks based on everyone's capabilities. Additionally, most of us had never used Jira or Confluence before and didn't really know how to use them effectively. Having a greater familiarity with these tools, for example by reading their respective user guides, would have helped streamline our project organization and planning.
To begin a project with many moving parts, it's crucial for a team to adopt techniques in order to manage time, people, and progress. Firstly, the team created a timeline in order to give estimates of when parts of the game were supposed to be finalized. This is adopted through Java's sprint feature, which keep tracks of work delegations amongst the group. This technique had a very positive effect, as members could easily access which work was assigned to them and take initiative to start work that had not already been delegated. Furthermore, during times of high communication, virtual meetings were created in order to more effectively communicate. If a member could not make a meeting, meeting notes were created in order for absent members to read and catch up to speed. This worked particularly well, as having 8 team members with different schedules made scheduling meetings very difficult. Lastly, the team used a tool called LiveShare in VS Code. This allowed the team to work on code in real time, similar to Google Docs. This worked extremely well, as the team did not have to create numerous pull and push requests that could cause merge errors and overwritten code. Ultimately, these techniques led to higher efficiency in team communications and workflow.